When the theory of computation was first discovered by Babbage and then developed by Alan Turing during the 1930s, it wasn't realized that this was a branch of physics at all.
Yes.
It was invented as a branch of mathematics to study mathematical proofs. And the theory was built up from a conjecture that a certain type of abstract object, the Turing machine, could represent all things that could be computations. Now, what quantum computers, and then historically what happened after that is that people began to worry that the physical world might not be able to instantiate these operations perfectly, and that therefore the real world might be a weaker kind of computer than the Turing computer, that it might be an idealization. Now, when we studied this more carefully, and this is where quantum computers begin to come in, we found that not only can a universal computer exist physically, but it's more powerful than a Turing machine. And what the mathematicians were doing unconsciously is that when they invented these abstract objects, they were applying their intuition about physical objects. They didn't know that that's what they were doing. And because they were applying their intuition about physical objects, they got it wrong. They thought about computing, making marks of squares of paper, and then, as Feynman remarked, they thought they understood paper. But in fact, paper, like everything else, obeys quantum mechanics, and the real computation in the world is quantum computation. The theory of computation is the theory of quantum computation, and that is a theory of physics. So that means that the theory of computation is irretrievably within physics because of the quantum theory of computation.